using autograph then to plot these functions. So what we're going to do, this is following on from the power functions little video, is to plot these values on autograph. We're going to plot log of I against log of p. So these are the values that are going in. We could do it by hand and draw a line on graph paper by hand and find the equation of that line of best fit. But we can use autograph to do it as well. So let's see how that works. So fire up autograph. And that's on the computers downstairs in the HE study area, so you should find it on there. If I go right across here, it goes weird over here, so what we do is we just expand it down this way, make it as big as possible. Now then, there's all sorts of things you can do with autograph. Let's just drag this over here a bit so I can see that toolbar. This button here allows you to enter a data set, which we're going to do in a second. This button allows you to enter an equation, which we're going to do in a second, because we're going to put the equation of the line on. So, enter a data set. If you hit that button, a little data box comes up, and I put my x values in first and then my y values. If I decide I want to change them around and do the graph the other way, I can just swap axes, which is this button here, which is quite handy. So what we're going to do is put our x and y in. So the first two results are just, the first one, x was, log I was 0.146. Hit return and you go to the next data point, which is 1.69. Hit return again, next one, 672. Return, 2.742. Okay, so, and then you're going to put more in, okay, but let's just look at the first two data points. Hit OK, and we can see them, and it's probably going to go off screen. So these buttons then come in handy. We can zoom out on the axes, and if I want to zoom out, wherever I click, it tends to center it. So make sure if you want this graph to stay in the middle, you click roughly in the middle, and you'll see the data points. If all the data points ended up lying, say, in this square, which they might well do, then this is a convenient button to use, this square zoom box in. So I drag a box around the part of the graph I'm interested in, which might be this square here, and then it just focuses in on that square. Now, I've got my data points on, and this is where the software comes into its own. First of all, I can confirm it's a straight line, so I confirm it's a power function. Hopefully that's what you'll get. Then, and this is where it gets really interesting, I put in the equation of the line. I enter an equation. Y equals mx plus c. So I literally type in the equation of the line and hit OK. And it enters that equation. It shows a graph of the line y equals mx plus c. And by default, it says it sets m and c as 1. So if I go to the constant controller, which is a button up here, I know it's a lot to take in, but you're all computer literate, and you can play around with it, and I'll be around to help anyway. If you hit that, any letters that you've assigned, apart from y and x, it will assume a constant. So all of the letters you put in, apart from y and x, will appear as a drop-down menu in here. So m and c appear as constants, and I can change the values of them by either changing it, literally typing in a new value, or by increasing and decreasing. You can see I can change the slope of the graph, the gradient. Remember, m was the gradient. Can decrease the gradient, increase the gradient, and then what I've got to do is get my line to fit the data points, and then I can read off from this box here what m and c are, and they will give me the values that I want in my power function. Okay. To get the line in the first place, James, you go to this button here, enter equation. If you can't find the button, if you go to equation, and then you see it there anyway, enter equation. By the way, if you also can't find the data box, go to data and again enter data set. So it's up there as well. But yeah, just type in y equals mx plus c and you've got it. Okay? How? By going to the constant controller and adjusting the values as near as you can. Line the best fit through the data. Yeah. Okay. So